Next we will explain about procedure in MASM. Procedure is similar to function in high level languages. So this is the format for procedure: definition, procedure name, proc, near or far, then body of the procedure, return statement, then again procedure name and NP. This is how we can define a procedure. So we can give some identifier for this procedure name, and this proc is an assembler directive, near or far, this is also another assembler directive. Then body means what we have to do in this procedure. Then this RET instruction is equivalent to return statement in high level language functions. Okay. Then at the end of the procedure, that will be marked by procedure name, NP. NP is another directive. Then what is the significance of near or far? This will specify the how we can access this procedure. That means if we are specifying a near here, if we are defining a procedure as a near procedure, then we can access that procedure only from within the segment in which the procedure is defined. And if we are defining specifying this as far, then we can access the procedure outside the segment in which the procedure is defined. That is the significance of near or far. Okay. Example, if we are defining a procedure to display a message. So in this case, in the case of a procedure, we can supply the input arguments to this procedure through registers. Here we are supplying these input arguments ds. This input to this is simply a procedure to display a message. So the inputs to this procedure are the segment and offset address of the string or message to be displayed. That will be given through ds register and dx register. This is our procedure. Display message is our procedure name. This is our directive for creating procedure. Then it is defined as near. That means we can this procedure will be available only to the segment in which it is defined. Then this is actually the body, move h, 09h int 21h. That will display, that we already know that this will display a string ending with a $sign. Then return statement. This is to return to the called program. Then display message NP, that will mark the end of the procedure. That is about the procedure definition. Then next is how to call or how to invoke this procedure. For calling a procedure, we can use the instruction, call instruction, then followed by procedure name. So here we are calling call display message. So before calling a procedure, we have to initialize the input parameters, or we have to supply the input parameters through registers. Here the input parameters are segment and offset address of message, but this segment address is already given through the ds register by the assembler directive .startup. So we have to only specify the offset address here, that is given through the dx register. Then we will call the display message. So that will the procedure will be invoked, or control will goes to that procedure, and the corresponding action will be done. Then another problem with this procedure is some procedures or the procedures may create side effects. That is, inside the procedure to execute that particular task, we have to use some registers, and the content of that registers may change during the execution of that procedure. So that will affect the called program, because that will affect the calling program, because in that program that registers will be used for some other purpose, and after calling this procedure the contents of that registers may be lost. So to avoid that, to overcome this problem, or to eliminate the side effect problem, we can use the help of stack. That is, we can save the register values into stack at the entry, at the starting of our procedure body, and we can restore that values at the just before the return statement. So in this procedure, the value of the AH register is changed. We are changing the value of the, because move AH, 09 is used, so that will change the value of AH. So what we are doing is, at the starting we will push the content of AX. Actually the content of AH is changing, but to store into stack we can only store in 16 bits. That is why we are pushing AX. We will store, or will save that value, AX value, into stack. Then after executing this body of this function, we will restore that values from the stack, that is pop AX. The content of the stack will be restored into AX register again. Then we will return from the procedure. Okay. So we can use stack to save register values and to restore register values. That will eliminate the problem of side effect. Now we have defined a procedure. The next is where to place the, where to arrange this procedure in our assembly language program. So we can arrange, or we can place the procedure after .exist and before the end statement or end directive. So in this program we have arranged, or we have written the procedure display MSG after .exit. This is display MSG proc near, then display MSG NP. If you have more procedures, then if you have another procedure, suppose display display num is, assume that display num is another procedure, then display num proc near, then just body, after that display num NP. Similarly we can here the body will be there, body will be here, body and return. We can define a number of procedures in between .exit and end directives. Okay. Then how it is used here. Okay, this is similar to our previous program. .model small stack 100h. Okay, we have defined three string variables, msg1, msg2 and new line. This msg1 db hello gcskpm, this is our first message. msg2 db hello csc is our second message. The new line is another string with the characters 10, 13. These are the line feed and carriage return. Then this is just for creating a new line. Then .co.startup. Okay, here we are calling the display message first time. Okay, before that we are specifying the input parameters for this procedure. the input parameters are segment address and offset address of the message. This segment address is already specified through the dot startup, that will initialize the data segment register with the segment address. So we have to specify the offset address to dx, that is move dx comma offset of msg1, then call display msg. Then next we have to just display a new line. For that purpose, move dx comma offset of new line, then call display message. Then to display the second message, move dx comma offset of msg to call display msg. This is our program in which we have used the procedure display msg. Okay. Next, we can just execute this program. For that, we have to take our DOS box. Then I have saved this program in a folder, hardware lab, present in my home folder. So we have to mount, then C slash home slash irshad slash hw lab. Now drive C is mounted as local directory home irshad hardware lab. So while mounting, we have to give the complete path of our hardware lab folder. So if you are doing in Ubuntu, we have to please note that this path separator is forward slash instead of backward slash. Okay. But this DOS box or in Windows, the slash will be backslash. Okay. Now another setup is we have to set the path also. So for setting the path, set path is equal to current path followed by C colon slash. Here the slash is backward slash backslash, because this is the DOS box slash. Okay, slash MASM 611 slash bin. This contains our executables for assembler and linker. Okay. Move to our C drive. C colon. Now we are in C drive. Then to assemble, we can give MASM. Then our program name is proc1.asm. That is our program name. So now it is assembled. Then to link proc1.obj, because after assembling, obj file will be created. So that will prompt for the name for executable and other files. Just type enter, again enter, again enter, again enter. Then an executable with the name proc1.exe will be created. And to execute that one, we have to just type proc1, then that will execute hello gec skpm, then hello csc. That will be displayed in separate lines. First one will be displayed in first line, then after a new line, next message will be displayed. Okay, this is how to execute our program. Okay.